We're going to look at a few more examples using the exponent properties. In the first example, we're going to multiply and simplify 3x to the third y times a negative 4x squared y to the fifth. Now, all of these quantities are multiplied together. We have 3 times x to the third times y, and then that's times negative 4 times x squared times y to the fifth. By the commutative property of multiplication, we can then rearrange all these products and group them together according to the type of term they are, the type of base they are. I'm going to group and put the 3 times the negative 4. I'm going to put the x cubed times the x squared, because those are the same base. And then I'm going to put the y next to the y to the fifth. And by doing that, now I can apply the exponent rules. Before I go further though, just to remind you that y by itself is y to the first. So I'm going to make that replacement. Now we do the multiplications. 3 times negative 4 is negative 12. X to the third times x squared, we use the multiply rule for exponents to get x to the 3 plus 2. Y to the first times y to the fifth, we use the exponent rule for multiplication and get y to the 1 plus 5. This then becomes negative 12 times x to the fifth times y to the sixth, and then that can be just written as negative 12 x to the fifth y to the sixth. In the next example, we're going to multiply and simplify 3x squared times the quantity x cubed plus 2x plus 4x to the fourth times the quantity x minus 1. In this problem, we use the distributive property, we're going to group like terms, and we're going to use the multiply rule for exponents. First thing I do is I rewrite the problem here, but then what I do is I take that minus 1 out and I replace it with plus negative 1. This is an important step when using the distributive property. You either have to do this or you have to think through this. Whenever you see the minus 1, think plus negative 1. Now I apply the distributive property. I have 3x squared times x cubed plus 3x squared times 2x. I apply the distributive property to the second set of terms, and I get 4x to the fourth times x, 4x to the fourth times that negative 1. Now all of these products are added together. I apply the exponent rule for multiplication. 3x squared times x to the third, I add the exponents, 2 and 3. Then I take 3 times 2 times x squared times x to the first in the second product, and I've sort of done that in these two steps in one here. The 3 times 2 gives me the 6, and then the x squared times x gives me x to the 2 plus 1, because x by itself is x to the first. In the third set of terms multiplied, I have 4x to the fourth times x. Again, x by itself is x to the first, so I get 4x to the 4 plus 1, that 1 coming from the x to the first. And then the last set of terms that are multiplied, we have 4x to the fourth times negative 1. That just makes a negative 4 times x to the fourth. Now what I'm going to do is simplify these. I get 3x to the fifth plus 6x to the third plus 4x to the fifth plus the negative 4x to the fourth. Now there are two like terms here, and these are the 3x to the fifth and the 4x to the fifth. These can be combined into 7x to the fifth. The other two terms are not like, so we just write plus 6x cubed plus negative 4x to the fourth, and we can write that as 7x to the fifth minus 4x to the fourth plus 6x cubed. In this last example, I'm going to multiply and simplify the quantity 2x squared y to the fifth raised to the third. This involves this extended power to a power rule. We're going to raise each factor to that third power. We're going to raise 2 to the third, we're going to raise x squared to the third, and we're going to raise y to the fifth to the third. 2 to the third is just 2 times 2 times 2, or 8. x squared to the third, we multiply exponents. Remember the power to a power rule. You multiply the powers together. Y to the fifth raised to the third, same thing. Multiply exponents, get y to the 5 times 3. We simplify these and we get 8 times x to the sixth times y to the 15th, which we can just write as 8x to the sixth, y to the 15th.